Hello and welcome to the Redemption separate build demo. This is a demo, a simple shell scripting demo. The demo itself consists of a code base we're going to repair and the redemption tool itself. The parts of the demo that we're looking at now is there's a README file which basically will step us through it. The README file you can see here in all its marked up glory. It actually consists of a bunch of shell commands. Execute this command and then execute this command and so on. And in these commands, and I'll be entering these commands into several shells to execute them. In addition to this README file, there is a good directory here, which contains several files that kind of show the answer keys, what we should be producing. For example, as part of our demo, we're going to create a compile commands.json file, and if the file we create matches with the one that's in here, then we know that our demo is working smoothly. So with that said, I will move on to our demo. So what I have here is an Emacs window with 3 buffers. The top buffer is the same README file that I've been showing you already, and the bottom 2 buffers are shells that are currently pointing to the same directory. Yes, and ls. So as you can see, these contain the exact same things. However, we will be using the 2 shells for 2 different purposes. The shell on the left, so the point of this demo is to repair some code that we cannot build in our redemption container. The shell on the left will contain a container that is useful for building the code but cannot repair it, and the shell on the right will be useful for repairing the code, but it cannot build the code. The code we're going to repair is called work. It is a web benchmarking toolkit. It's a small program of about 10 C files, freely available from GitHub. So the first thing we're going to do is launch our leftmost container, the one that we can build work in. Now, in order to build work here, we have to actually install some external software. So I'm just basically copying commands from the README file into the shell command and executing them here, where it's going through the steps of adding these things. So now with these things added, I can now go into the work directory and execute the build command here. And it will build about 10 files and then complete. And as you can see, there's now a work executable, which will basically give us a nice little help screen here. I'm going to clean this up now. Now, as I said, this has the ability to build the code. However, it cannot repair the code. And to show you, I will simply list host code acr. There's a special directory that doesn't exist in this container, but in the container I'm going to put in the right shell, it does exist, or it will exist. So now, we will launch the redemption container, and first of all, I can show you that this has the redemption code in it. You know, this is the same directory that doesn't exist on the left. It does exist on the right. However, in the I'll just go ahead and try the build on the right container, just simply to show that it cannot build properly. So it's the same command that worked in the left container. It now fails because there's no OpenSSL /SSL.h that was installed in the left container but not in the right. I could always install it in the right container, but that wouldn't make for much of a demo now, would it? So at this point, our 2 containers are set up, and the next step is to start the process of repairing the code. So the first thing we have to do, and these commands will be done in both containers, the first thing we have to do is create the compile commands.json file. We have to do this in the left container because only the left container can build the code. So we're basically doing the same make command as we did before, but this time we're also running a program called bear, which monitors the make and produces the compile commands.json file. So I have to move the compile commands.json file up one directory, and now I'm going to diff it with its parent. First of all, I'm just going to simply show you a little bit of this file. So this is basically a whole bunch of build instructions saying, with this source file, compile it with the following arguments. Now, the important thing again is this the correct file? Did I produce it completely correctly? And the way to do that is to compare it with the good directory, the good directory's copy. If these two files are identical, then diff will return with nothing. If they're different, then it will give some output saying what the differences are. But there's no differences, so everything's working correctly. Yay. Moving on, we have to run static analysis. In our case, we're going to be running clang tidy. We're supposed to be in the work directory. We are already there, so I'm just going to run this command, clang tidy, which produces a clang tidy.txt file. It produces a whole bunch of errors. I think clang tidy actually calls the things that it finds errors, some errors and some warnings. Don't worry, the demo is still working. These are errors it's supposed to be finding. Once this is done, I'll do a diff of the clang. I'll show a little bit of the clang tidy file, and then I'll do a diff of it with the good directory. It should be done in a few seconds here. Okay, So basically what clang tidy produces looks like a lot of compiler errors. They're not compiler errors, they're more issues of that, you shouldn't include some file, or you should be doing A when you're doing D, and so on. So again, the more important thing is to diff it with its parent, or with its good analog. And it's correct. So the next thing is that we convert the errors that clang tidy produce into a JSON format that Redemption can take. Redemption can take the output of several different analysis tools, and clang tidy is just one of them. So we convert them all to a format for Redemption. This we have to do in the Redemption container. So I'm going to put these commands into the Redemption container. I'll quickly show you that the clang tidy.txt file does exist because both of these containers are sharing a file system. So here we go. We're going to produce an alerts.json file, and now we'll diff it with its good counterpart. And it's correct. So I'll just show you the beginning of alerts.json. And again, this is simply the same compiler errors that you were seeing on the left, but they're in a JSON format, so they look a little more formatted, more easy to understand. These also indicate certain rules that clang tidy thinks are being violated. The first alert here is about int31-c, for instance. Okay, so with that done, we're ready to run Redemption. So normally we would run Redemption as just one command to repair everything. However, that would assume that we can run clang in the Redemption container, and for this demo, we can't. I mean, we can always run clang in the rightmost container, but as you saw, clang was going to get errors because, ssl.h is not in the rightmost container. So instead, what we're going to do in the right buffer here is create a shell script to run clang. We're going to run clang in the left window where we can do it, produce some output, and then we're going to feed that output into the right window. So phase one is where we run the first half of Redemption. It just simply produces a run clang script back here, and I'll show you a little bit of that too. So first of all, I will just simply execute these commands, and these commands run pretty quickly again. Okay. Now, if we go into this directory, I'll show you that there's now a run client script. I'll first of all compare it with its good analog. Okay. Actually, I don't think this script is 100 lines long. Right, it's not. So all it is it takes a directory, and inside that directory it puts several, well, it runs client in that directory to produce several output files. They end with either LL or AST JSON GZ. And there's one such command for each source file in work. So again, what that actually does is actually not something we need to worry about. But we are now going to run this client script. So first of all, we want to do it in the work directory. So I'll cd there. I will make dir/temp. And then we will run the script inside, or run the script passing it the new temp directory as output. It takes a little bit of time, only a few seconds. And now that it's done, there's a whole bunch of output files. Again, the LL files and the JSON, the AST JSON files are basically produced by Clang and they're fed to Redemption. So now all we need to do is pass this temporary directory to the right window, and Redemption will do the rest. So we will do these commands next and do them in the Redemption container. Now this will take a little while because it's basically digesting, it's iterating through each of the files. Actually, it's iterating through each source file. So for instance, for zmalloc, what the last file it's going to do, but it has to parse the AST JSON GZ file and the LL file, figure out which alerts apply to zmalloc, and then apply those repairs. Now each repair is going to go into an out directory, into the legacy/out directory, and we can compare that legacy.out directory with an analog in the good directory. So just to show you, oops, it's ... So there are 5 files, sorry, there are 10 C files in the good out directory. And as you can see over here, it's finished and it's prepared about 10 C files. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first of all, I can again compare so these outsource files were created and we can compare them with good outsource. And again, if this repaired things correctly, then diff will return nothing, it returned nothing. However, the more interesting thing is this command, which diffs the outsource directories with work. So what this is simply doing is comparing the repaired sources with the unrepaired sources. I'm actually going to blow up this window to take the whole screen so you can see its output because there's a lot of it. So first of all, in the original source, there's a whole bunch of non-C files that are not repaired. That's fine. But in each source file, such as ae.c, there's differences. In the repair, there's an include acr.h. Down here, we initialize some variables to null or 0. Another equals 0 initialization. Some more initializations here. We include a null check somewhere down here. What you're seeing here is mostly variables that were declared but not initialized are now initialized to be set to be 0 or null or 0.0. Here's another source file. There are some source files that exist in the source but do not exist in the repaired output file. That's because the redemption tool did not make any repairs to those files. Again, every source file has an include acr.h, which is part of the repair because it provides some useful macros. However, yeah, some files had no changes made to them whatsoever. So continuing on, here we go. Here we go in zmalloc, actually the last file. Here is Here's a pointer, well, a pointer to an integer, and we actually dereference the pointer in the unrepaired code, but in the repaired code we check that the pointer is not null before we dereference it. And then we do that again down here. So this is a null check. This is the other type of repair that's done. So it's actually near the beginning of zmalloc. But that is how our repaired redemption code works. And that is how you can use redemption to repair code that cannot be built inside the redemption container.